就随意传讯。然后他希望又写了30给大家来，把他讲的离他才认识那种，对对，所以就也 post 啊，然后放上去，所以他讲 three type，他项目都被写 execute and then three type of the data source，然后我们就懂了一个。它总共15个，它每一地方都15个，然后不能把少扣一点。
Okay, good afternoon guys. Seeing you all to the break. I hope we are here. Let me show the title because we are coming back after our break. So, touch base. We are in PDA. We are in PDA. And I remember we have discussed the example problem on polygon. And one day also we have discussed, right? We have discussed one day, right?
Yes.
Oh. A length and B length to when? No, everyone. We haven't discussed the answer for this. No one? Okay. I mean, you can be honest. Don't mean just say no. We can do it, not a problem. Okay. Because I also don't remember this. It's 1 week. Okay, just to recall, some of you may have confusion with the push and pop. Okay. So if we look at this as your stack, so in PDA, before processing a string, the stack must be empty. Okay, and after processing the string, again the stack must be empty. Okay, this is a pre-condition. Okay, stack must be empty before and after processing the string. Okay, so you can see the stack is empty, and we have discussed that stack follows LIFO principle. Last in, first come. Okay. To manipulate the stack, manipulate means to work on the stack. There are only two instructions, namely push and pop. Okay. When we say push, something will be pushed on top of the stack. When the stack is empty, this is the top of the stack. Okay. So when I say push A will be pushed here. Okay. Pushed on top of the stack. Okay. So if I say push B, now top of the stack is not this. Next vacant location. This is the vacant location, right? So push B means it will be pushed on top of the stack. Okay. Here. So if I say push C, it will be pushed on top of the stack. Okay. So now, when we want to pop, right? When you say pop, we can only pop from the stack top. We can only pop this. We cannot pop this or pop this. Okay. Yeah, it's like the stack is like a container. Okay, so once you have a stack, that's why you got the name stack. Stack means putting putting something on top of another. That's what is stack of books. You know, stack of cards. You know, stack of biscuit packets. Okay, that's why this got the name stack. Stack means putting one on top of another, piling on one on top of the other. So when we say pop, for example, if I say pop C, this will be popped off. So if I say pop B, this will be popped off. When I have something like this, I cannot pop A. This is not possible. You have to remember, push means write something into the stack. Pop means read something from the stack. Okay, and you have to understand. So when we say pop, reading something from the stack. Push means writing something to the stack. Okay, clear? Huh? If this is clear, then it makes our life easy. All right. So now we have a language here that says language is equal to a length n, b length, sorry, b length to n, where n is greater than 0. Oh my God! I didn't realize. That's why I was wondering, what is this? I'm skidding. I didn't realize what I did. Oh my goodness. Possibly rain. Hello. This will go okay. No mind. So I have to avoid this place. So A length n, B length n, length to n, where n is greater than 0. Greater than 0 means n takes a minimum value 1 and maximum value is infinity. Okay, 1 to infinity, right? That's the value n can take. So when n takes a value 1, A repeated 1 times, B repeated 2 times 1. A repeated 1 time, B repeated 2 times. N is 2, A repeated 2 times, B repeated 4 times. There is no comma separating here. So meaning A's have to be followed by B's. That is the pattern, only pattern. Okay. A's followed by B's. And what is the number of A's and B's? The B's are always twice the number of A's. The B's are always two times A. That's simple language. Okay. So to me, when I have B's twice the number of A's. So what is the thought process? How to manipulate this in terms of a stack. So I draw the stack here. I draw the stack just for our understanding. You no need to draw the stack in the test or exam. Okay? If you want to draw, you can draw. There is no much for this. I am showing this to visualize. Why to visualize? Because PDA uses stack as a memory to process something. Okay, so easy to understand what the PDA does. Okay, so when I take the first example string, okay, ABB. This is my first example string. So my thought process is very simple. I need to ensure the B's number of B's is always twice the number of B's. Right? The number of B's is always twice the number of B's. So how to ensure that? If you observe carefully, basically with the push and pop in a PDA, most of the time we'll be doing counting. We'll be doing counting with the help of push and pop. So if I have one count of A, I need to have two counts of B. If I have two counts of A, two counts count number. If I have two counts of A, I need to have four counts of B. Okay? So how to do that in terms of push and pop? So my thought is very simple. So A means, what I will do is, I will say, I'm programming the PDA. Okay? So I'm just visualizing the stack, not the machine yet. Okay? So A means, my thought is very simple. I will say, read A, push 2 A's into the stack. So read A, push 2 A's into the stack. So you may ask, why you are putting only one character in one location? Why don't, can I do like this? Cannot. Why means, when you pop, pop means read, right? When you pop, you cannot pop one year on. If if you push 2 A's like this, you have to pop both the A's. Because read means it will read the entire cell. You can't do a partial read. Okay? Technically, there is another reason how the memory is organized, but I'm afraid if I go there, then I have to recall your computer architecture and organization. Right? There you should have learned about memory hierarchy and all that, RAM, ROM, EEPROM, static RAM, dynamic RAM, random access memory and all that. Okay? Memory even today, memory means we always mean main memory, the chip, memory chip, not the hard disk. Even today, memory is organized as bytes. Memory is a group of locations, right? So what is the smallest location that can be read or written by the processor? How big it is? Okay. What is the smallest location that can be read and or written by the processor? It is 8 bits. Okay. All our keyboards are ASCII keyboards. Okay. So when you press one key, a 7-bit ASCII code will be generated, plus 1 bit for parity. This also you should have studied in your computer architecture and organization. Error detecting and correcting codes, parity check method, hamming code method, cycle redundancy code method. Okay. These are the popular error detection correction algorithms to learn. Okay. So 7-bit ASCII plus 1 bit for error detection, 8 bits. So when you press anything, any device, you press a key, and 8-bit code will go to the 8-bit code. Technical reason why we put only 1 letter. Understood? Okay. Because it is normal. Even if I'm sitting there as a student in class, sir, why you are putting pushing 2A means you write like this. Can't I push 2 A's in the same location? Technically, I have given 2 reasons. Okay. This is seen as one location, it is 8 bits. Okay. Another reason is, if I push like this, I cannot read 1A, I have to read both the A's. Okay. That's another reason. So my thought is A means I push 2 A's. Okay. When it comes to B, I only pop 1A. Okay. So read B, pop A. Read B, pop A. So number of push and number of pop is the same. But when I pushed 2 letters for 1 letter. Right? Yeah. So by doing this, what I am doing is I am checking whether the number of B's is twice the number of A's or not. Okay. So A means what I am doing? I am pushing 2 A's. Okay. So B means I pop only 1A. Again B means I pop 1A. This is the thought process. Understood? Yeah. So now I am going to reflect this thought in terms of a machine. Okay. So start state. Okay, start state. So we call this as look ahead. Look ahead means when I look at the problem, I don't look just this problem. I also look at subsequent problems, subsequent example strings. Okay. So when A means in this situation it's just going to be. So A means what we did. If the input alphabet is A, what is the top of the stack? The stack goes like this. Top of the stack is empty, right? So how do we represent the empty string? Lambda. Okay. So I'm going to say A means if the input alphabet is A, push A. Correct, right? So we can call this position as push, or we can call it as stack replacement. Currently the stack top is empty. Now we are replacing that with A. Currently stack top is empty. We are replacing it with A. Meaning we are pushing A into the stack. Understood? See, what confusion arises to students is whether this is stack top or this is stack top. Don't think like that. When you push, we can only push something on top of the stack. Next vacant location. Next vacant location is this one. Okay, if you ask me, can I push B here? Cannot. That is why it is called as push down. So when you push, it goes to the bottom. That's why I said the next vacant location is this. The next vacant location is this. Next vacant location is this. When you pop, it's something like opening a biscuit tin. And usually what we do, we only take the biscuit or the biscuit packet on top of the tin, right? Of course, if you want to be different, you say, no, I will put my hand, grind to the bottom and I pull some down from the bottom. That is exceptional cases. Okay, usually we take only from the top of the jar or top of the tin, biscuit tin, right? Yeah, same thing here. When you pop, you only pop something from the top of the stack. So this is the top. Okay? So if you remember this, your life is easy. Okay? I'm sorry.
我负责抓鱼找人过来看。
这样我要手指把谁控制？我要手指把谁？
不用可以。
可以吧？
我们25。
就少了。
不好吗？生活不易。
看你那个台，小白虎。
啊？
那时候就大找一个手车，光台不小白虎。那个。你说那个，你说78岁。
我
可是被打不管我事。
我给你好一点，我说18岁，说28岁，我怕我先跑。
我怕等下在地铁就抢了。
带自己不要带人，就是因为你带自己需要带人，对学生也会看其他时候带起来。你在讲那人家也是都是简单起来的，到学校就带着。
不要穿那种封闭的衣服。
而且我说了，别人看我亲人穷。
不会穿波浪的，白色。还有早饭的。现在不用肥皂，不用肥皂，不用全部不用肥皂。
我们决定。
这是啥？快点！
这个我也要学，这个我也要学。不要会的。
你有怕？
你懂？你好感觉不懂。我们看，我们机票也差不多。如果你跟他一样选菜，就便宜。
可以啊。
88。
So yes, my cost calls. Alright, So A means what you're doing. Currently, the stack top is empty here. So we are pushing A into stack. Understood? So we can see this as the current stack top and new stack top. Okay, current stack top is empty, and now the new stack top is A. Okay, so when we say new stack top is A, when we say push, we can't push here. We can only push here. Here, yeah. When you pop, you can only pop this. This is empty. What you're trying to pop, if you say I want to pop something from here. Here, so push A. So in this case, I push A means, sorry, I need to push 2 A's, I'm sorry. Push 2 A's. Because I need to check whether I have 2 B's or not. So one time A means I push 2 A's. So for every B, I can pop an A. Okay? So what I'm going to do is, so if the input is B, now the input is B, right? So A means we push 2 A's. So B means I'm going to say pop A, pop 1A. Okay? So pop 1A, yeah? So what I'm saying is replace the top of the stack which has an A with lambda. Replace the A at the top of the stack with lambda. Replace the top of the stack which is an A with lambda. Meaning you have replaced the A here with lambda. Meaning you have popped the A out. Okay, yeah? We have popped the A out. So we have one more B, right? So we do the same here. So B means read A, write lambda. This is how I do. This is how the process does. Read A, write lambda. Read A, write lambda. Just replace this A with lambda. So I have popped the A. Done. That's all. You have to make this as a final state. This will work for all the valid strings. For example, A means we push 2 A's. Again A. Go through this because the machine is still here. Machine is still here now. Maybe you can label it as Q0 and label it as Q1. So again 2 A's. Machine is still here. Q0. So now B means the machine will change state from Q0 to Q1 by doing this, implementing this. So B means if the input alphabet is B, read A, write lambda, pop this A. Machine is at Q1. Again B. B input means read A, write lambda, pop this A. Again B. Read A, write lambda. Again B. Read A, write lambda. Entire string has been processed. Stack is empty. Machine at the final state, halt and accept. Okay. So what happens if you give invalid string? I take A, B, B, B. Invalid string, right? So A means push 2 A's into a stack. So B means no choice, machine will transit from Q0 to Q1. So B means it will pop the A. Now again B. So B means pop the A. Now B means instruction here says machine is the machine is here. Instruction here says B means read A, write lambda. Pop A from the stack. Stack is already empty. Right? So from empty stack, we cannot pop an A. Okay? So this instruction cannot be implemented or this input as well. So the machine will halt here. Even though it is a final state, this is not processed yet. If it has to be processed, it means this has to be completed. This is not processed because B means instruction says pop A. I cannot pop A from empty stack. It's a stack violation. Okay? So halt and reject. Even though machine halts here, the entire string has not been processed yet. Before the entire string can be processed, stack becomes empty. Okay? So halt and reject. Okay? I can have something like this as well. Just AB. This also is an invalid string. Okay? So A means, you see, before processing the string, stack is empty. So A means read lambda, push 2 A's. I push 2 A's in the stack. So B means machine will transit from here to here. B means it just says read A, write lambda, pop this A. Entire string has been processed. Stack should be empty. Machine is already here, but stack is not empty. Entire string has been processed. Entire string has been processed. Machine is here. The stack is not empty. What is our precondition? Before processing a string and after processing a string, stack must be empty. Okay. Since the stack is not empty, even though the machine halts the final state, this is halt and reject. So ignore it. Clear? Everyone is with me? Clear, huh? Okay. And that's what you see as the answer here. Okay? Okay. Let me do this, and maybe I'll give you directions for D. D is that's all can be solved, and I'll tell you why. And maybe I will solve 3, and I'll give you directions for you to solve 2. Okay. Even though 3 says assignment 1 task, I will still do it because I have not taught one particular instruction which I am going to teach by doing 3. Yeah. Let's quickly do 2. Sorry, 1B here. Sorry. Let's quickly do 1B. I'm going to show and do for you. 1B says language is equal to A length I, B length J, C length A. Again, you see there are no commas. It means A's followed by B's followed by C's. That's the pattern. Okay. But now the question comes: when A's followed by B's followed by C's, how many A's, how many B's, and how many C's? Okay. We call this as loop variable because this is a loop. I, J, K are the loop, right? How many times I defines how many times A can be repeated, J defines how many times B can be repeated, K defines how many times C can be repeated. Right? I defines length of A, J defines length of B, K defines length of C. Okay, yeah? So now the I, J, K values are defined here. I is equal to J or J is equal to K. Okay? I is equal to J or J is equal to K. And what is the min-max value I, J, K can take? It is given here. I, J, K is greater than 0. Meaning minimum value I, J, K can take is 1. Maximum value I, J, K can take is infinity. Okay? So now, when I is equal to J, what are the possibilities? A, B, right? Length of A and B should be equal. Right? How about C? I call it as I don't care. You get me? Because the condition here says I is equal to J or J is equal to K. You understand me? I is equal to J or J is equal to K. Meaning length of A and B are equal, or length of B and C are equal. Say what is length and all? Can you say in very simple English? Number of A's and B's should be equal, or number of B's and C's should be equal. Clear? Number of A's and B's should be equal, or number of B's and C's should be equal. Understood? Everyone? So I is equal to J means number of A's and B's should be equal. We don't care about C. So we don't care about C means C can be 1 or more times. I don't care. What I care, number of A's and B's should be equal. So I can have this as my smallest possible string. I can have like this. Etc. So length of C, I don't care. Length of A and B, I care because condition is I is equal to J, right? Or J is equal to A. So j is equal to k means length of b and c should be equal. Number of b's should be equal. We don't care about the number of a. So a can be one time, like here. Here a can be one time, b can be two times. So b two times means c also should be two times. You can have something like this. I am not even counting. What we can, number of b's and c's must be always equal. We don't care about the number of a's. Here, number of a's and b's must be equal. We don't care about the number of c's. Okay. So I is equal to j or j is equal to k. Okay. My simple thought is, so I will follow this path for I is equal to j. I will follow this path for j is equal to k. Because it says I is equal to j or j is equal to k. You get me? So I is equal to j means what? We should ensure length of a and b should be equal, right? So how we can do? Length of a and b equal. A means push A, B means pop A. A means push A, B means pop A. A means push A, B means pop A. Number of push and pop are equal. It means number of A's and B's are guaranteed to be equal. Correct, right? So what we do for C? That's why I use the word I don't care. So I don't count the C. I ignore C. So meaning I don't do anything. I don't do push or pop for C because I need to only ensure the number of A's and B's are equal. So how to reflect this thought here? So I'm going to say A means push A. Right? A means push A. We are looking at this. B means pop A, right? What is next? C. But okay, let me show. C means I simply say ignore the stack. I go here. Don't draw. It's not correct. C means I say ignore the stack. So A means push A, I already pushed A. So B means I am saying pop A. Machine is still here. C means ignore the stack. Ignore. Why I am saying ignore the stack? I am saying lambda stroke lambda. I am neither pushing nor popping. Here means pushing. Here means popping. Correct, right? Here lambda stroke lambda means C means I am not doing anything to the stack. I am neither doing push nor doing pop. So meaning I am ignoring the stack. Okay, I am already here. This gets accepted. But this string cannot be processed. A means push A. Again, A means push A, right? Correct, right? So we can have 2 A's, 3 A's, 4 A's, 5 A's, infinite number of A's. Correct, right? So what should we do? So this will tackle or handle any number of A's to be pushed into the stack. So A means I say push B, push A. Now B means pop A. Again B means I need to pop the A. I can have any number of B's, right? Now C. C means I ignore the stack. I come here. I make this as a final state. Again C, I can have something like this. So A means push A. A means I'm already here. A means again push A. Now B transits here. Pop A. B, pop A. C goes here. I have 3 more C's. So what do? I loop it here. C, ignore the stack. C, ignore the stack. C, ignore the stack. Entire string has been processed. Machine is here. Stack is empty. Order answer. Okay? So I is equal to J. Done. We are going to do J is equal to K. Here we ignored C. Here we are going to ignore the number of A's. We need to ensure the number of B's and C's are always equal, right? So what I'm going to do is, I'm going to say A means ignore the stack. A means go here, ignore the stack. Here also A means go here, ignore the stack. A means go here, ignore the stack. But here I have many A's. Right? So I need to loop it here. Say A means ignore the stack. So this will handle if I have any number of A's. Okay? So I've ignored all the A's. Now only I'm going to process the B. So B means I'm going to say, you can even say push A, just for a change. I'm going to say B means push B into a stack. You can even say push A into a stack, no harm. What you push, you just pop it off, that's all. Okay? What you push, you're just going to pop it off. You can even, B means push A. Yeah? You want to push A or you want to push B? Which you want to push? B means you want to push B or push A? Push B, just for a change. You always say push A means push A, right? Just for a change. You can even say push A, no harm. So B means, I'm looking here, B means push B. But I can have many B's, right? So what I do is, I loop it here. So B means, again, push B. Maybe we will trace this. A means, I'm ignoring the stack. A means, I'm ignoring the stack. Machine is here. Now B means, machine transits to this state. B means it says push B. Read lambda, write B. Right? Again B. Loops here. B means again push B. Now I have C. So C means what should I do? C means I should pop this B. Read B, write lambda. Machine is here. Again one more C. So C means read B, write lambda. And let's pop this B. Entire string has been processed, stack is empty. So this should be the final state. A, B, C. Here also A, B, C, right? A means ignore, B means push B, C means pop the B. Okay? Yeah, good question. These are alphabets. Okay? When we say capital A, we call these capital letters as stack alphabets. Meaning, when we say A, small letters are alphabets. So when we say A, instead of pushing the alphabet itself into a stack, okay, we push a symbol into the stack. Okay, so the idea is I'm just counting. Okay, so not necessarily I need to push this alphabet. I can push any symbol I want. That's why I said we can use capital A, capital B, capital C, up to capital Z, any letter you want. Because what we are doing is we are just trying to see the number of push and pop are equal or not. Okay, here the number of push and pop should be equal for A and B. Here the number of push and pop should be equal for B and C. That's all. Okay, that's why instead of pushing the alphabet itself, we push a symbol. So these capital letters are called here in PDA as stack alphabets. Sorry, yeah, stack alphabets or stack symbol better. Stack symbol. Okay, symbols that are used to push or pop from to the stack. Push into the stack or pop from the stack. Okay, what are stack symbols? Okay. Cap letters are called as lexicals. Small letters are the alphabets of the language. Okay, clear? Clear, huh? Okay. Actually, I can simplify this. How means, huh? A means push A means push A, right? I can just bring this here, like Tai Chi here. Just move this here. So, what I'm doing is, it's the same. So, A means I just say push A, that's all. So, this will handle 1A or any number of A's. Huh? So now B means I say pop A. B means I say pop A. This becomes, sorry. I'm sorry. Yeah, correct. A means push A, B means pop A, right? Something going. Pop A, right? Pop A. So C means ignore the step. So I say one statement. Both the answers are perfectly right. Okay. So only thing is here I have saved one statement, reduced one statement. So I am doing the A looping in here. You can go home and check, just trace and see, give some invalid string whether it answers or not. Okay. So for example here, I just give BC. Length of B and C are equal. A is missing. Here, in this case, so B means it says pop A. It cannot work. Correct, right? What happens if you go in this direction? It cannot progress from here to here, you know. You need to have at least one A to go from here to here. The string starts with a B. So the machine will be stuck here. In this direction also it will be stuck because here there is an instruction for B, but it says pop A. Stack is empty. So it cannot process in this direction. Can it process this inverse in this direction? Cannot. Because here, if you want to move from here to here, you need to have an A. You have to start with A. Right? So you cannot process this string. Okay? Okay, I have can I have an invalid string here? Invalid string you can have only if you sequence if you change the sequence. Because if you say A, B, C, C is a valid string. Because A, length of A and B are equal. Okay? If you say I can give invalid string the sequence also. If I give A, B, B, C here, is it valid or invalid? It's an invalid string as well. Why? Length of A and B is not equal. Correct, right? I is not equal to J. Correct, right? If I look BC, length of B and C also is not equal. So I is equal to J, doesn't work. J is equal to K also doesn't work. Correct, right? So it's a perfect invalid string. So what happens if we give this string? So A means, let's see, this is why I show the stack because it's easy to see. Okay. So A means push A into the stack. Push A into the stack. A has been processed. B means it says pop the A from the stack. Okay, I popped A. Again B, machine is here. B means it says pop A from the stack. Stack is empty. So the machine has processed only up to here. This B cannot be processed. C is still yet to be processed. So before the entire string can be processed, the machine halts here. And the stack is also empty. Halt and reject. Okay. So you can go and try, that is how you learn how to trace. Give some invalid string, see what happens. Okay? Any questions before we move further? Okay, time is 12:50. C says assignment one task, but I will do it. So A is done, B is done. C I will do it in class. D, what D says is the language L is equal to set of strings that are element of A or B star. This colon is same as the vertical bar. Okay? We can use the vertical bar or we can use the colon. So this means where it should not be read as W equals to W power R. You should not read like that. Yes, in mathematics, pure maths, we read like that. W is equal to W power R. But here, in automata theory or compiler theory, we read this as string is equal to reverse of the string. Clear? Thought later come and ask me, so what is W power R? How to interpret this? That's what I'm telling you. In pure maths, of course, it is absolutely right. We read it as W is equal to W power R, but this is not pure maths. It is compiler theory, how compilers are constructed, the theory behind compiler construction. Okay? This is read as string is equal to reverse of the string. String is equal to reverse of the string means what it means is it says the string is made up of any combination of the alphabets A or B, because you have a comma here. Any combination of the alphabets A or B, the string here, pattern is same as the reverse of the string. The string is same as the reverse of the string. String is same as the reverse of the string. So if I take the string to be A, B, A, the reverse of the string, normally we read left to right, right? Now I am going to read right to left. A, B, A. It's the same. So whether we read left to right or right to left is the same. The string is same as whether we read in the forward direction or we read in the reverse direction. Okay? If W is equal to A, B, B, A, then reverse of W is equal to also A, B, B, A. A first, B next, B next, A next. Okay? For this, what we call this? The string is same as reverse of the string. A palindrome. Correct, right? And we have already seen that here in the example question that is solved. Okay? Only difference is how the question is specified. Here it says set of string an element of A or B where the string is a palindrome. String is a palindrome. Same question. Here instead of saying string is a palindrome, it says string is equal to reverse of the string. This also means a palindrome. So instead of saying palindrome, we are saying where string is equal to reverse of string. String is same as reverse of string. So question is the same. How it is specified is different. Okay? So answer you can copy from there, paste it here. Okay, that's why I said it can be solved like that. The answer is already there. With the way the question is specified is different. Okay? So this one I am going to give you direction and you can do it. I will show the attendance. Before going to attendance, let me explain that after attendance you can leave. Construct a PDF or a language over A or B where the string contains the same number of A's and B's. So what do you mean by same number of A's and B's? If there's one A, there is one B. If there is two A, there is two B, that's all. Okay? But what can be the example strings? Example strings. Now I understand why they put the chat here. Example. So what can be the example string? I can have something like this. I can also have something like this, right? The question simply says where a string contains the same number of A's and B's. For a language over A or B. Language over A or B means the alphabets are A or B. Any combination. You can start with A, start with B, end with A, end with B, does not matter. What matters is the number of A's and B's must be always equal. One time A means one time B. A could appear first, B could appear first. If I have 2 times A, I should have 2 times B. But for this, there are many combinations. I can have like this, I can have like this, I can have like this, I can have like this. Understood? Etc. Only the count means the number of A's and B's matter. They should be the same. Order does not matter. Okay? So what you should do? What is the logic behind it? Yes, A means push A, B means push B. A means push A, B means pop the A. So here B means push B, A means pop the B, that's all. Okay? Same thing here. A means push A, again A means push A, so B means pop the A, pop the A. So A means push A, B means push B, B means push B. Now B means pop the B, A means pop the A. I already told the instruction. Just push and pop, that's all. Right. But there are two ways of drawing the state transition diagram. Let me open the caps so it explains. So there are two ways of constructing the PDA. So maybe in the next class, that is on Thursday, you can share me the answer. We will discuss and we will finish PDA on Thursday. Yeah, here you go. Any questions?